Hello everyone. In this lecture I shall discuss the extended Runga method of fourth order in solving the system of simultaneous equations as well as solving higher order differential equations. If we recall the first order differential equations and its solutions by the RK method, we have the necessary formula is yn plus 1 is equal to yn plus 1 by 6 times k1 plus 2k2 plus 2k3 plus k4, and here n is greater than equal to 0. Okay, and subsequently substituting 0, 1, 2, 3, we will get y1, y2, y3 so on up to the desired accuracy as asked in the given interval. Now we can extend this study to system of simultaneous equations as well as for the higher order. So before that, let me to introduce myself. Myself Professor S.K. Paikray, currently working as a Professor of Mathematics at Veer Surendra University of Technology Burla in Sud Visut, Odisha, India. So without much delay, let me to discuss the extension of these methods. Now consider in previous case we have dy by dx is equal to f of xy, y of x0 is equal to y0. Here simultaneously we are given dy by dx is equal to f of xyz and dz by dx is g of xyz with condition y of x0 is equal to y0 and z of x0 is equal to y0. So likewise here k1, k2, k3, k4 with here fxyz, right, we compute k1, k2, k3 and k4, and likewise with here gxyz, right, with here gxyz you compute L1, L2, L3, L4, and consequently you write the formula now, and we simultaneously compute ki and li with what is here k1 is equal to hf xn yn zn, and what is here k2 or L1, you find L1 is equal to here hf z1 zn xn yn zn xn yn zn. Then you find k2 is hf xn plus h by 2 yn plus k1 by 2 and here zn plus this L1 by 2. Okay, zn plus here L1 by 2. So these two are interrelated, right? These two are, because we substitute this here, so combinedly we are solving. Okay, combinedly we are solving. Then here L2 is equal to, then here L2 is equal to, here L2 is equal to H, this is G, this is Hg xn plus h by 2 yn plus k1 by 2 and zn plus L1 by 2. So L1 is here. Then you find here K3. Here K3 will be equal to HF xn plus h by 2 yn plus k2 by 2 and here zn plus this L2. Okay, this L2 by 2, and at the same time you compute L3. Here L3 will be Hg xn plus h by 2 yn plus k2 by 2 and here zn plus L2 by 2. Then finally you compute here k4 is hf xn plus h yn plus k3 and zn plus L3. So L3 is from here. At the same time you find here L4 is equal to Hg here xn plus h, yn plus k3 and zn plus l3. Okay, L3, and with this you compute now yn plus 1 is equal to yn plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4, and here zn plus 1 is equal to zn plus 1 by 6 l1 plus 2 l2 plus 2 l3 plus l4. Okay, so with n is greater than is equal to 0, and you substitute all this value here, okay, you substitute all this value here and you get the solution. Now if you are given a higher order differential equation, then how to deal with that? Now for higher order differential equation, the intention is reduce to system of equation. Okay, how to do that? You substitute y dash is equal to z, put y dash is equal to z. So that means d square y by dx square is nothing but y double dash is here dz by dx. Accordingly, here y dash x0 becomes here z0. Okay, accordingly we have here z of x0 is equal to z of x, this one z, y dash becomes here z of x0 is equal to here y0 dash. Okay, so now this equation is converted to a system of equation. One equation is y dash is equal to z, z means my f of xyz, and another equation is my this becomes converted to y double dash is equal to g of x, y and z with initial condition y of x0 is equal to y0 and y dash x0 means here z of x0 is equal to here z of x0 is equal to here y dash 0. Okay, so now this is reduced to the system of equation. Okay, now this is the system of equation, system of two equations. Now once we reduce to the system of two equations and we approach in the previous way, find k1, k2, k3, k4, l1, l2, l3, l4, and accordingly you find ki and li. I is equal to 1, 2, 3, 4. Thereafter you find the solution. Okay, and you solve it. So the illustrative example will give you the better understanding. Let us solve the example as below. Now you are asked to solve the simultaneous equation this and this with the initial conditions at x is equal to 0.3 by using RK method of order 4. The same also can be solved by the extended Euler method. Now coming to the solution here let this is fxyz, this is your f, and this is your, bringing this to that side it will be your g. So let fxyz is equal to your 1 plus zx, and gxyz is minus of xy with here x0 is equal to, this is your x0, this is your x0, this is your z0, right, this is y0 and this is your z0. So x0 is equal to 0, y0 is equal to 0, z0 is equal to here, z0 is equal to here 1. We need to compute what? We need to compute what is y of 0.3 and z of 0.3. So choosing h is our own choice. Let I choose h is equal to 0.3, so that I have to perform only one step. Since the method is itself lengthy, we try to minimize the number of steps looking into the time. So here let h is equal to 0.3. So this implies what will be here x1 will be 0.3. Accordingly we will compute y of x1 and we will compute z of x1. So this is our intention. Okay, so now we compute k1. So what is my K1? I am not repeating the formula again. I write the K1. What is my K1? K1 is equal to HF x0, y0, z0, because I need to perform only one step. Only one step I need. Only one step I need here. Right, only one step. If I choose h is equal to 0.1, then 3 steps are needed. 3 steps are needed. Okay, but I want to minimize this step as the method is itself lengthy. So this is my HF this. At the same time, what is my L1? At the same time, my L1 is, and L1 is here HG x0, y0, z0. So what is the value then? So this is here 0.3. It is f of here x0 is 0, y0 is 0, z0 is 1. So this is equal to, the function is 1 plus zx, right, 1 plus zx. So this is 0.3 into 1 plus z, means 1 into 0. So this is here 0.3. So it is here 0.3. And what is my L1? And here L1 is equal to, right, hg 0, 0, z0 is 1. So this is minus of xy. So h is 0.3 into minus of 0 into 0. So this is equal to here 0. Right, this is equal to here 0. Now what is your K2? Now your K2 is equal to HF x0 plus h by 2, y0 plus k1 by 2, z0 plus l1 by 2. So L1 is here, right? So this is equal to my 0.3 f of 0.15, 0.15, and it is my 1. So this is equal to 0.3 into here zx plus 1, 1 plus zx, 1 plus here zx 0.1 into 0.15. Okay, so this is equal to here 0.345, 0.345. And what is my L2? My L2 is equal to hg x0 plus h by 2, y0 plus k1 by 2, y0 plus k1 by 2, it is y0 plus k1 by 2, and it is z0 plus l1 by 2. Substituting all this thing, we have h is 0.3, it is g of x0 plus h by 2 0.15, y0 plus k1 by 2 0.15, and it is z0 plus l1 by 2, it is 1. This is equal to 0.3 minus x into y, minus 0.15 into 0.15. So this is equal to 0.00675. So this is your L2. Now you find your K3. K3 is equal to HF x0 plus h by 2, y0 plus k2 by 2, and z0 plus l2 by 2. L2 will be substituted from here. So this is equal to my 0.3 into f of 0.15, 0.1725, 0.996625. Okay, if we simplify it, it will be your 0.34485, and accordingly your L3 will be, hg x0 plus h by 2, y0 plus k2 by 2, and z0 plus l2 by 2. Okay, likewise if I simplify it, it will give me 0.3 into minus of 0.15 into 0.1725. So this will give me, this is 0.3, so this will give me minus 0.0077625. Okay, finally what is my K4? My K4 is equal to HF x0 plus h, y0 plus k3, Z0 plus L3. Okay, so this is equal to 0.3 f of 0.3445. It is 0.99224. If I simplify it, it will give me 0.3893, and accordingly here L4 will be Hg x0 plus h, y0 plus k3, and z0 plus L3. Okay, and this value will be 0.3 into minus of 0.3 into 0.34485. So this is equal to minus 0.03104. Okay, now we are ready to apply the formula. Now what is my y of x1 is my y of 0.3. It will be y0 plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. If I substitute all these values here, this will give me, so substituting the value of k1 k2 k3 k4, we have this value of y of 0.3 will be 0.34483, and here similarly substituting L1 L2 L3 L4 and Z0 will be getting 0.98999. So this is the answer. Okay, so let us solve one more example for second order differential equation. Now coming to example 2, we are given a second order differential equation, d square y by dx square minus x square dy by dx minus 2xy is equal to 1 with initial conditions. We have to find y of 0.1 using RK method of order 4. Now coming to the solution, consider d square y by dx square minus x square dy by dx minus 2xy is equal to 1 with y0 is equal to 1 and y dash 0 is equal to 0. Y dash 0 is equal to 0. Now we need to substitute dy by dx is equal to z. We have to substitute this as z. Okay, as the working rule I have mentioned above, let put dy by dx is equal to z. So this implies d square y by dx square differentiate with respect to here x. I am getting dz by dx now. Okay, so that this given differential equation will be of the form, it is dz by dx minus x square z minus 2xy is equal to 0. At the same time this equation will be, there will be no change in this, y0 is equal to 1 and this y dash becomes my z, z0 is equal to 0. So now I have these two equations, I have, this is my system of equations. Okay, this is now converted to system of equation. This is my f and accordingly I find what is my g. Okay, so let us find that. Clearly the reduced system of equation, system of two equations is as follows. Here dy by dx is equal to z is my fxyz and dz by dx is equal to, actually the right hand side is here 1. Okay, the right hand side is here 1. So this is my right hand side and this is my reduced system. Now this is my reduced system. So here solving dz by dx becomes here 1 plus 2xy plus x square z. Okay, with the conditions here x0 is equal to 0, y0 is equal to here 1, y0 1 and here z0 is equal to 0. So let I choose h is equal to 0.1. Okay, I want to minimize the steps, so h is equal to 0.1. so in one step, so we need only one step is enough, one step with n is equal to 0, right? One step is enough to achieve the result as y of 0.1. So now we find k1, k2, k3, k4 as in the previous case. So now my k1 is equal to hf x0, y0, z0. So that is equal to my 0.1 f of 0, 1, 0. So it is my z only. 0.1 into 0 is 0. At the same time, what is my L1? L1 is my hg x0, y0, z0. So this is equal to my hg 0, 1, 0. So this is equal to 0.1. It is my g is this is my gxyz, this is my gxyz. So my g is 1 plus, it is 1 plus 2 into 0 into 1 plus 0 square into 0. Okay, so this is only 0.1. So this is only 0.1, right? Now I find what is my k2. K2 is my hf x0 plus h by 2 and it is here y0 plus k1 by 2, y0 plus k1 by 2 plus z0 plus l1 by 2. So this l1 will come from this l1. So this is equal to my 0.1 f of 0.051, 0.05. Okay, so this is equal to here only z only, so h into, so this is 0.1 into z only 0.05, this is equal to 0.005. and accordingly what is my L2 I need to find. My L2 is h f of h my g of the same thing, it is 0.05, 1, 0.05, and you simplify it, it is here 1 plus 2xy plus x square z, h into 1 plus 2xy plus x square z, is not it? It is here x, it is here y, it is here z, and if you simplify it, here L2 will be 0.11. Then you find here k3 is equal to hf x0 plus h by 2, y0 plus k2 by 2, k2 is this, and here z0 plus L2 by 2. So L2 is my this. So this is my h f of 0.05, 1.0025, it is 0.055. So if I simplify it is 0.1 into 0.055. So this will be my 0.0055. At the same time I need my L3. L3 is my hg, this is x0 plus h by 2, y0 plus L2 by 2, and my z0 plus here sorry, it is k2 by 2, it is k2 by 2 plus z0 plus L2 by 2. This is L2 now. So now I simplified, it will be my 0.11004. Then I find my k4 is hf x0 plus h, y0 plus k3, z0 plus L3. Okay, so this is equal to my h f of 0.1, 1.0055, and it is z0 plus this, it is 0.11004. okay, if I simplify it, it is 0.1 into z, 0.11004. so this is equal to my 0.011, and accordingly my L4 will be hg x0 plus h, y0 plus k3 and my z0 plus L3. So this L3 will be here and this K3 will be substituted here. Okay, so these are all interrelated. So after simplifying, I will be getting 0.1 g of the same thing, 0.1, 1.0055, 0.11004. Okay, so if I substitute it, so we will be getting 0.12022. So now here we have to find only y of 0.1. okay, y of 0.1. now my y of x1 is y of 0.1 is y0 plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. Here L is not required. Okay, so if I substitute all this value, it will be, if I substitute all the value, k1 is 0, k2 is 0.005, k3 is this, k4 is this, so it will 1 by 6, 0 plus 2 into 0.005 plus 2 into 0.0055 plus k3 is here 0.011. so this will be equal to my 1.0053. okay, so to conclude, like the extended Euler's method, we use the extended Runge-Kutta methods to solve the system of equations as well as the higher order differential equations. Okay, so this is very useful, and as I have mentioned earlier, this Runga-Kutta method is most important to get the desired accuracy in comparison to other methods. Though the process is lengthy by manual calculation, but if you set a computer programming, then within no time we get this answer. Okay, so let us close this lecture here. Thank you all. If you like this lecture, that you feel that it is interesting and helpful, please like and subscribe. It will boost my motivation to upload subsequent lecture for your benefits. Thank you all. Have a nice day.